Muscles are the unsung heroes of our bodies. They are the engine behind every move we make, from a gentle wave to a powerful leap. More than just movers, muscles provide our bodies with shape and structure. Imagine a building without its steel frame, it would simply collapse. Similarly, muscles are the scaffolding that holds us upright and allows us to interact with the world. They are essential for everyday activities like walking, running, and lifting. Even seemingly simple tasks like breathing and digestion rely on the coordinated efforts of various muscle groups. Muscles are not static structures, they adapt and change based on the demands placed upon them. This remarkable ability to grow and strengthen is what makes it possible for us to improve our physical capabilities. Whether you're an athlete striving for peak performance or an individual aiming to maintain mobility and independence as you age, understanding how muscles grow and adapt is key. The human body is a marvel of interconnected systems, and the interplay between the brain and muscles is a prime example. Every movement, from blinking an eye to running a marathon, begins with a signal from the brain. This signal, an electrical impulse, travels at lightning speed down the spinal cord and branches out through a network of nerves called motor neurons. These motor neurons act as messengers, carrying the brain's instructions to specific muscle fibers. When the signal reaches the muscle fibers, it triggers a cascade of events that leads to muscle contraction. This contraction generates force, pulling on the bones to which the muscles are attached, and voila, movement happens. The complexity of this process becomes even more apparent when we consider the sheer number of muscles and motor units involved in even the simplest actions. Think about the act of walking. It requires the coordinated contraction and relaxation of dozens of muscles in the legs, hips, and core, all orchestrated by the brain with remarkable precision. Contrary to popular belief, muscles don't grow by magically multiplying their fibers. Instead, muscle growth is a fascinating process of damage and repair. When we challenge our muscles with resistance training, we create tiny tears in the muscle fibers. These microscopic tears are not a cause for alarm, they are a necessary part of the growth process. Think of it like remodeling a house. You have to tear down walls and remove old fixtures before you can build something bigger and better. Similarly, these microscopic tears signal the body to initiate a repair process. During this repair process, the body uses amino acids, the building blocks of protein, to repair the damaged fibers and build them back stronger than before. This increase in muscle fiber size is known as hypertrophy, and it's the fundamental principle behind muscle growth. Just like a construction crew needs the right materials to build a house, our bodies need the right nutrients to fuel muscle growth. Protein is especially crucial as it provides the amino acids necessary for muscle repair and growth. Adequate calorie intake is also essential as it ensures that the body has enough energy to support the demanding process of muscle building. Hormones also play a pivotal role in muscle growth. Testosterone, often associated with masculinity, is a key anabolic hormone that promotes muscle protein synthesis. Another important hormone is insulin-like growth factor, or IGF-1, which stimulates muscle cell growth and proliferation. While these hormones are naturally produced by the body, their levels can vary significantly from person to person, influencing individual muscle building potential.